Hey listeners, it's Paul Andriola here. Why not join our community at Small Cap Discoveries, where we offer our members direct access to some of the best microcap investment opportunities available. Our members are getting access to premium microcap financings, research reports, and direct access to management. Sign up today at www.smallcapdiscoveries.com.
Hi, everyone. Welcome to the Small Cap Discoveries conference call. Today on our call, we have the CEO, Leslie Klein from CCOM Satellite. CCOM trades on the TSX Venture Exchange under the symbol CMI, and it also trades on the OTC under CYSNF. The company is currently trading at $1.05 with about 42 million shares outstanding, or about a $44 million market cap. I'd now like to hand it over to Paul Andriola.
Hey, thanks, Trevor. Yeah, I had the pleasure of meeting with Leslie a couple weeks ago at the Planet Microcap Conference. What really intrigued me here is this is the first chance we've actually had to speak at that conference, but I've been following the company for a number of years. It's in the satellite industry, which I think we've talked about in a couple of our past discussions about where we think the satellite industry is going and some of the innovations around there. So it's a pleasure to have Leslie here with us today. Would love to find out about the company, Leslie, and more about some of the things you're working on. So thank you for joining us today, and I'm just going to turn it over to you. I'll help you run your presentation here, but welcome, Leslie.
Thank you very much, Trevor and Paul. Thanks for the introduction, and welcome everybody who is online. I'll be happy to give you a little background on the company. And if Paul can start going past the disclaimer, we'll launch into the business itself. The company was started by me in 1997, so it's about going to be 27 years old. And it was one of the first companies that developed communication on the pause type of technology, which is essentially an antenna system that delivers high-speed broadband over satellite into vehicles while on the pause, which means that we are actually stationary while the communication is continuing. And when we are finished communicating, the antenna stows on top of the vehicle or a trailer or any transportable structure, and you can then move to another location and repeat the process with a press of a button. So the technology is very advanced. It has been improved over many years, and we are a very small company, only 33 people. And we don't manufacture anything. Everything is outsourced. And we are working on some very interesting new developments with regards to electronically steered antennas, which I'm going to discuss with you. Next slide. So the company has sold over 10,000 of these antennas. You can see it on a picture of a vehicle there when it's deployed. We are actually active in 106 countries with 600 dealer partners, resellers who buy the product from us and sell it to their clients. So we have no presence other than in Ottawa, from where we ship the product. We manufacture everything in Canada, and some of the manufacturing is done in the Toronto and Ottawa areas. And we bring the product back into Ottawa. We do a final testing of it. We have about $7 million worth of inventory, and we then ship the product to the reseller, who generally pays for it in advance. So the company has virtually no receivables. I don't think in 27 years we had one bad debt. The company, as Paul mentioned, is profitable. It has been profitable for many years. It pays dividends. It has about $23.5 million worth of working capital and paid out about the same amount in dividends over 46 consecutive quarters with zero debt. We've never raised any more money than the first time in 2001. I think we raised when we went public with and raised about $5 million. So the return to shareholders has been significant over the number of quarters that we have provided them with dividends. Next. So the company manufactures a number of antennas for the worldwide market, and the vertical markets that we address, as you can see here, are numerous. from oil and gas to mobile banks to cellular backhaul, mining companies, disaster emergency response, disaster recovery, military, government, etc. So wherever the connectivity is required, and there is very little of it in most places around the world, our antennas deliver high-speed broadband in much the same manner as you will get it in downtown Toronto or downtown Vancouver. There are a large number of potential customers in the commercial market that we are addressing who need these type of applications. Next. So this is a map that shows some of the 10,000 antennas deployed. Interestingly enough, you can see that a very large population of the antennas are in areas where you would think that there is plenty of connectivity, like North America and Europe. And the situation is that most of those customers who need on-demand bandwidth, and they need a lot of it, cannot get it from any other source than satellite at the moment. And so interestingly enough, if you look at New Zealand, it's packed from end to end. Every fire department, every fire truck in New Zealand has one of our antennas on it for disaster recovery. In case there is an earthquake or a fire, the fire truck is able to deliver connectivity wherever it goes, even if there is power failure everywhere, because the power comes from the generator in the car. So these are the advantages of the antenna, that it can be used even when there is a massive disaster somewhere. The satellite is still up there and the connectivity exists while the terrestrial infrastructure is destroyed. So these are the advantages, one of the advantages of having a satellite connectivity available in a vehicle, for example. Next. So this is a lineup of our antennas. They actually break down into driveaways, which sit on top of a car, flyaways, which can be on a tripod and can be rapidly transported. And what we have also is fixed motorized antennas, which are typical VSAT satellite antennas that don't move other than on a pole. They are set up on a pole, but they move in azimuth elevation and polarization. So it means that these antennas can be deployed in very remote areas and left alone. And in case there is an earthquake or there is a wind that moves the antenna out of alignment, these antennas are smart enough to align themselves back automatically. So we have them in very northern parts of Siberia, northern parts of Canada, in Australia, and other parts where you would need to fly somebody in for $2,000 or $3,000 for 2 or 3 days and align the antenna. Because in order to align the antenna to a satellite, you need some very specialized equipment. You need an engineer, satellite engineer, who will spend about 2 hours to point the antenna and find the appropriate satellite. So these antennas are used in those cases where you want to be able to connect and you don't want to send a technician out. Anybody can go and push a button if they are around, or remotely access the antenna and point it back to its original position. The driveaways sit on top of a vehicle, as I mentioned. The flyaways break down without any tools into those boxes that you can see. These antennas are different sizes, different frequencies, used in different parts of the world, where there are certain frequencies required, certain physical size of the antenna is required, a certain bandwidth is required. So this is like Lego. The entire antenna can be put together and taken apart without any tools within minutes, and with a press of a button on the controller, it automatically finds the satellite, sometimes in as fast as seconds. So we also have developed a MPAC, which I think I'm not seeing here on the picture, but you guys may see it. It's a backpack antenna that you can put together within 5 minutes without any tools, and it folds into a backpack. It's about 24 kilos, and you can carry it with you. A soldier can carry it with him anywhere they go, and within 5 minutes, they can deploy the product anywhere on top of a mountain or in a jungle and have satellite communication, high-speed satellite communication. Next slide. So these are just typical antennas designed for different companies like Hughes, Eutelsat, Viasat, and many others. So just give you an idea of what they look like and what the feed looks like. So we'll just probably go through them quickly because it's a little too technical. But if you have any questions about any specific one of them, you can ask. So these are Ka band and Ku band, which are different frequencies. Ka band is a much higher frequency than Ku band and delivers much more bandwidth. It also allows an antenna to be much smaller than a Ku band antenna, and the transmitter part of it is extremely inexpensive as compared to the Ku band, where the transmitters can be more expensive than the antennas themselves. Next. So this is just a different size, a 98 centimeter. You can see it works with practically every satellite in the world, anywhere in the world, and it has been approved and designed to work with a lot of the satellite providers. So it's probably one of the most advanced products on the market, and it's one of the 10,000 products that we have sold from Australia to Siberia over the last 20-some years. Next. This is a broadcasting antenna designed for a television station, for example. Is designed to be very aerodynamic, sitting on top of a vehicle, and it essentially allows broadcasting television or film or anything from remote locations right back into the studio. So it has special characteristics, very high precision, and we have quite a number of these all over the world, from the Middle East to Europe, where they're used by television stations. Next. So this is a flyaway. You can see it a little bit closer. It breaks down into those cases. This is a 1.2 meter. So the smallest one we have is about 74 centimeters, and even smaller is the Manpack, which is much lighter, much smaller, and it's all carbon fiber, very, very easy to carry. One person can carry it. But quite often you require these larger antennas to be carried by helicopter or by a truck into remote areas. And instead of having the antenna on the top of a vehicle, you can just have it disassembled, fit into these cases, and ship it either by plane, by helicopter, or by truck, and then assemble it without any tools at a particular location where you want to have connectivity. Next. So this is the Manpack that I mentioned. As you can see, there's a backpack. The whole antenna really fits into that backpack. It's all carbon fiber. It's very, very light. We sold over 200 of these to SoftBank in Japan for cellular backhaul. So in Japan, they have a lot of disasters, and SoftBank is the second largest cellular provider in Japan with 140 odd million subscribers. And so they bought 200 of these to disperse all around Japan, where they have regular typhoons and floods, and these antennas are then pulled out and deployed as when the cell towers are lost. So they're able to reconnect these antennas to become cellular backhaul products within minutes of a loss of a cell tower. So they're able to continue delivering broadband connectivity, cellular connectivity, using these antennas, because you don't need to know anything about the satellite. You just put it together. It is very simple to do. It's a Lego-like structure, and with a press of a button, you connect to the satellite, and now you have restored a cell tower that is destroyed. It may take a month or two to have the cell tower fixed. In the meantime, this antenna can provide the same type of connectivity. So you can just see the controller. It's a tiny little controller with a few buttons. All you need to really do is push a button. The controller is very clever. It knows where you are. It knows where the satellite is. It has a compass. It has a tilt sensor. So it senses the tilt of the antenna. You don't have to position the antenna. It will automatically look for the satellite that it's programmed to look for, and connects to the modem that it's attached to, and connects right to the satellite and starts connectivity, delivering broadband speed. So it's very simple to use, very easy to put together, very easy to take apart. And we just started selling this product to a number of militaries around the world, because they find it to be very reliable, very inexpensive compared to military spec products, which this is not. This is a commercial product, but it behaves and operates just as well as a military product at probably half the price. Next. So this is what it looks like. We just shipped actually 15 of these this week. to Asia, to one of our largest potential military customers, who we expect that they will buy many, many more. This was just for one branch of the military, and it was painted for them according to their spec, the color that they requested. So you could see the other one is a commercial product, and we just painted the same product green because that's what they wanted to make it look military looking. And it also has Wi-Fi capabilities, so you can set up the whole antenna from a cell phone if you have one, because it has a Wi-Fi connection. You can see the antennas protruding from it. And as I said, it's going to be a very hot product for a number of military customers. Next. Here's an example in BC, for example, how the MEMPAC is used. It was used for a television commercial in the mountains of BC, where they were broadcasting, the commercial, as the commercial was being filmed, they were broadcasting it live into a studio, and they were editing it in the studio, and then they were communicating back and forth. So that by the time the commercial is finished in the mountain, from the mountain, they have a perfectly finished product in the studio. So it saves a lot of money and a lot of time to bring this kind of communication into areas where there is absolutely nothing and no broadband capability at all. So we have a number of these with television production companies around the world and television stations as well. So this is just one application as compared to disaster management of cellular backhaul. Next. So here is an example of how it's used in Japan. For example, you can see it's being connected to a power source and is broadcasting as a cellular backhaul for SoftBank. And there's a person carrying it up the mountain. There's floods and disasters where destruction is happened. And we have sold over 400 antennas to SoftBank during the Fukushima disaster, when they have had this nuclear power station explode, and they lost about 400 cell towers. So we were able to replace those cell towers within weeks, because we have a very large inventory that we were able to help them. And so since then, they've been buying product from us in large numbers. Next. So these are some vertical market applications. You can see oil and gas is a very big market. So you can see pictures here of trailers and oil and gas rigs around the world, from China to Libya to the US, Australia, etc. Next. Satellite news gathering, I mentioned. You have television stations in Mongolia, in Belgium, in Pakistan. We have sold 50 antennas to one Pakistani television station. Also elections in Angola and Germany and in the United States. Next. Emergency response, we have fire trucks in Japan, for example, on the left-hand corner here. We have in Osaka, we have 25 fire trucks that are all equipped with our antennas, and they actually are roaming around in case of emergencies and disaster fires, and able to transmit very high quality video of locations where they need to have access and need to be able to assess the condition of the fire. We also have the SoftBank antenna there deployed with a cellular backhaul. You can see the cell tower coming out of the same vehicle connected to the antenna and delivering we were the first with SoftBank within days to be able to deliver cellular connectivity. Those people are all waiting to call to connect with that vehicle to let people know that they are alive. This was at the Fukushima disaster area. So it's a life-saving type of a product. We also have police command vehicles in Russia and fire trucks in China and Indonesia. Next. We also have mobile health units, including the mobile COVID vaccination clinic during the COVID situation, where Hughes bought. Hughes was providing the service to Walgreens in that vehicle for vaccinations and connecting people over the satellite to hospitals and to other venues that they wanted to connect to. We also have mobile ambulances in Siberia and breast cancer screening units in New Zealand, where they have this van in remote areas of New Zealand positioned and able to on location breast cancer screening. So the people who live in very remote areas there don't have to travel hundreds of kilometers to have their screening done. It can be done in this unit, and then the unit moves to another location and provides a type of service to the health service to the government. Next. Military, as I mentioned, is a customer. We have them in Poland, in Russia, in China, in the US, in Vietnam. All of these antennas that we are selling are dual-use products. So the military can use them, providing they don't use encryption, or we don't sell them encryption type of equipment with the antenna. So the antenna is just a typical, VSAT antenna for satellite communication, and the military can equip it in any way they want, but it's not an embargoed product. Today it is for Russia, for example, but in general, it's not an embargoed product, and the military can use it as well as civilians can use it. So it's a great product for us to sell across the board to anybody who is allowed to buy it. Next. Telecom, as I mentioned, cellular backhaul, it's a very big application for satellite communication. And so we have these telephone companies around the world, from Fiji to the UK to Malaysia, and also in China and other parts in Canada also, with TELUS and many others who are using it for cellular backhaul. Next. Mobile offices are interesting applications. We have sold 120 antennas to the South African government for a pension program. So these antennas that you see on the left side of the picture are actually one of the 120 lined up in there. This is a service that the South African government provides to their citizens by printing pension checks in very remote areas of South Africa. And these vehicles go all over South Africa and actually provide connectivity to the government, and they print pension checks to those people who they require these checks. So instead of mailing them, these are delivered in specific locations through the government to the pensioners. We also have similar applications in Argentina, where the government of Argentina is providing, through a satellite operator, passport printing capabilities in these vehicles. So it's much the same. It's an e-government type of an application, and there's quite a number of them around the world. Next. Mobile banking is these are ATM machines on wheels around the world, tourist locations, and also in Africa and in Europe, where they actually dispense cash. Some of them only allow you to fill the phone up with cash, others actually have cash in them. And so it's another vertical market that the resellers around the world that we have developed and sold quite a number of these antennas on these vehicles to provide mobile banking. Next. So we're getting to a situation here where I'm sure that many of you are aware that there's billions and billions of dollars being spent on constellations of putting the low Earth orbit satellites into orbit. Telesat is one of them that is about 3 years behind schedule, and they're building a constellation of satellites that will cover the whole world and will be a commercial type of an application. SpaceX is a consumer application, and so is Amazon Kuiper, that is going to start service sometimes in the next 2 years. So it is a very, very large market. It's over a $17 billion opportunity. And CCOM has started developing an antenna that will work with these satellites over the last 5 years with the help of the University of Waterloo. I'm a graduate of the university, and we have assembled a very bright team there over 5 years ago. Many of these were postdocs and PhDs who were doing their final education there, and they were working on the technology that we developed with them. CCOM owns the IP. We have over 7 patents already have registered with this technology, and we are at the final stages of assembling this product, and I'll show you what it looks like. Next. So the antenna is the size of a Canadian quarter. You can see it has 16 radiating elements, and they're like Lego. You put these together and you build an antenna from it. And this antenna is flat, it's conformal, it's electronic, and it is able to track multiple satellites with an electronic computer controller in there. And there's the parabolic antennas that you saw before, the legacy products that we manufacture cannot be used on these low Earth orbit satellites, because the satellites are constantly moving, and there are thousands and tens of thousands of them going to be up there. And so you need an antenna that can electronically switch between one satellite that disappears from the horizon and the other one that shows up on the horizon. And not only that, but at the same time, we are moving. So this will be an in motion type of an application rather than on the pause application. So next slide. So you can see the antenna, it's very, very small. And so you can build very, very large or very small antennas from it, depending on the customer's requirement. The antenna is also conformal. So it means that it can conform to various forms, and it can be, the transmit part of it can be different from the receive part of it. And it can do an electronic scan of 360 degrees and can find the appropriate satellite within milliseconds and switch between different satellites. So it's a very unique type of an application that is in Ka band also, which is a very, very high frequency solution. And as compared to some of these type of technologies in Ku band, like SpaceX, already exist, but this should deliver 15 to up to 50 times more bandwidth, because the frequency is much higher. And the antennas can be much smaller, can be much thinner. So this is the future of the electronically steered antenna market, which will be required for all these constellations, for self-driving tractors, for self-driving cars, you name it. Anything that will be using satellite in the future will be using this type of an antenna. And the beauty of it is that the way it is designed is that it will also be usable on the existing GEO satellites and MEO and LEO satellites. So it is not only going to be working with the LEO constellations, it will be backward compatible with the many thousand of satellites that are up there that they still have a 10 to 15 year lifespan. Next. So this is how you build an antenna. You start with a Canadian quarter size 4x4 subarray, and you build up a panel, and then this panel is ultimately a transmit or receive panel, and then it works under a radome, and it works with a satellite. Next. We also have one of these patents that we have developed. It's a special material. It's a phase shifter that is not using printed circuit, so it's not using chips. It uses a special material that will reduce, hopefully, the cost of the antenna dramatically. The cost of the material as compared to the cost of the integrated circuit is like pennies to dollars. So the ultimate connectivity of this product, this patented product, could reduce the cost of the antenna significantly, because there is over 2,000 integrated circuits in an antenna. And so if they are $10 or $5 or whatever, compared to 5 cents, the difference in the cost will be significant. And also there's another advantage of this technology is the very low consumption of power. So these are the things that we are still developing at the university. And CCOM now has an office on the campus of the university, and we hired all of the PhDs and postdocs that worked on this technology, and now they are CCOM employees and developing these type of patented solutions for us. Next. So you can see here, for example, a parabolic antenna, and not in comparison, but just to show you a transmit and receive panel, the difference between a physical structure that's heavy, it's large, and compared to little tiny thin panels that essentially provide the same type of capabilities. So that's the future. Next. So this is just a slide that shows you the flat panel antenna market going into from about 30,000 units in 2021 to 590,000 in the next 5 years, and they will be used in all these different applications around the world. So the market is going to be very large. It's estimated to be $17+ billion in the phased array type of antenna shipments. Next. Just shows that actual revenue the terminals that are going to be growing in this marketplace, and how the flat panel penetration rate compared to all in-service terminals is growing over the years. Next. So in 2021, we actually already tested, developed, and manufactured one antenna, which was a 1,000 element antenna. We tested it on a vehicle, we tested it over Telesat. And so from then there was COVID, before COVID, after COVID. And so we lost about 2 years. University was kind of shut down, the labs were shut down. So now we are finishing this type of an antenna that will be a 4,000 element antenna. So it will have four times as many radiating elements as the 1,000 element antenna, and it will operate if you go to the next slide, you will see how it is sitting on a vehicle. And the next slide will show you a train, it's a simulation. And the following slide will show you what it would look like on a plane. You could have multiples of these antennas, depending if you want to receive more than transmit, etc. So this is in general the presentation of the technology. The next slide. I am also going to briefly mention to you that we are just finishing this year a project that was funded by the European Space Agency and the Canadian Space Agency, and a couple of very large semiconductor manufacturers like Skyworks and NXP. And our antenna will be used in this, what they call it, the HAPS. It's a very high frequency antenna that we have developed based on our phased array antenna to deliver high-speed cellular connectivity, 6G type cellular connectivity from a stratospheric plane that flies at about 20-kilometer height. So it's significantly lower than the low Earth orbit satellites, and it will be able to beam cellular connectivity into the phones of people within the radius of 400 kilometers without cell towers. So this will eliminate the use of cell towers, and you'll have this high altitude plane. There's 3 of them flying constantly in the radius of up to 300 to 400 kilometers and delivering high-speed cellular connectivity at the next frequency level, which will be 6G, up to 100 times more bandwidth than what you're getting today with 5G. So this is a market that will be developed with the semiconductor manufacturers who will be providing the chipset into the phones, but the connectivity from the HAPS, from the plane to the satellite and back down will be done with an antenna similar to what we have developed. So this project has been fully funded. It's finishing this year, and we are going actually a final testing over the next 2 months of this concept. So the big saving here is that cellular operators will eliminate cell towers. They will not need cell towers. So they'll be saving up to, for example, with a 400-kilometer radius, they'll be saving $400 million if they would need 400 cell towers, for example. And they could deploy this plane anywhere in the world in areas where they would never put cell towers in because there's either not enough population or the cost of putting those towers in is very high. So this is a next type of technology that will be a very interesting development over the next couple of years. And we hope to also play a role with this development. Next. You can see on this link how this will work. SoftBank has bought a number of planes already, and we have worked with them initially a number of years ago on this concept, and they are actually testing this concept themselves. The companies that we are working with are actually semiconductor manufacturers. So SoftBank as a service provider is looking at this concept to launch a service by themselves. So it's an interesting link. If you have a chance to look at it, it gives you an idea of how this HAPS mobile solution works. And it's of course the latency which is time to respond to an instruction from a device like a plane flying at 20 kilometers, is much higher than, or much lower than a satellite, because satellites are in hundreds of kilometer heights compared to 20-kilometer heights. So there's certain advantages, and cost would be one of them. I mean, the planes are less than $1 million compared to some of those satellites that cost much more to launch and to maintain. So it will be a very interesting opportunity for us to continue working on this. Next. And that's my presentation. Thank you for your attention. If you have any questions, I'll be happy to answer them.
Leslie, thank you so much. I mean, that's fascinating stuff. Definitely, I want to learn more here. You answered a number of the questions that I had here, more specific to sort of the size of the market that you're operating in. It sounds like the antenna market for you right now is about a $17 billion opportunity. Does that sound right?
That's correct. Yeah. So
okay, perfect.
Even a small portion of it that we would be able to gather will change rapidly the structure of the company, the profitability of the company, the sales, and all of that.
No, clearly. Now you talked about all the different products. Give us a sense of what the cost is for these products, and what sort of margins you make when you sell one.
So the products range from as low as $20,000 to as high as $75,000 to $80,000, and we have sold some specially built products in the $150,000 and higher range, requiring very special transmitters and other equipment. But on average, the oil and gas companies, for example, that we sell a lot of products to, it's about $20,000, and the margins are up to 65%.
Yeah, perfect. And some of the new products, especially this flat panel product that you're talking about, can you give us a sense of where you think the costs are going to be? I know it's early stage, but where do you think the price point is going to be, and what your cost to make this stuff?
Our goal would be to leave it in the same price range, in the $25,000 to $30,000 range, but giving it mobility. Now, a lot of the factors that we have no control over is the cost of the integrated circuits, the availability of the integrated circuits that we are building into these antennas. So if those come down in large volumes, I mean, if you build 1,000 antennas or 500 antennas, you'll be buying tens of thousands of, or not, almost hundreds of thousands of ICs. So much like the PCs, you will see a reduction in volume of those. So hopefully we can drive that price down from where the original estimate is today to something affordable. But I don't think price is an issue. If you look at some of the aircraft antennas, for example, they're in the hundreds of thousands of dollars. And so if we can have a $35,000, $40,000 $40,000 antenna that can be fit on an aircraft, for example, that would be a very, very reasonably priced product. But we are not planning to actually build aircraft specific antennas, but we will be selling the guts of the system to people who build them, and they would then market them as such, buy the technology from us, buy the antennas themselves, and then they package them as an OEM to many different applications, either military or marine or trains or whatever.
So you're like that Intel Inside sticker that we see on computers all the time. Yeah, that's perfect.
That's
perfect.
The idea, yes.
Yeah. I want to remind everybody that's listening, if you've got a question you'd like me to ask Leslie, please use the chat function and I'll fire the question off. Leslie, I mean, you've been in business for quite a while now. You successfully, moved the company to profitability, and you've been sort of consistently generating profits for a number of years. But what challenges do you face right now? Either, pandemic probably brought in its own challenges, but right now, where do you see your challenges?
Well, the challenge is, we tended to be quite lucky or smart or both. For example, the supply chain management issue, we just received some parts that we ordered 2 years ago. So that gives you an idea of what's happening in the marketplace. But we have sourced those parts 2 years ago because we knew we needed them, and we could not get them from the manufacturer. So we had to go to China, Israel, wherever somebody had 50 or 100 of these, so that we could build these antennas that we need to sell. And as a result of it, actually, 2 or 3 of our competitors have gone out of business because they could not supply the product to the customer, and they could not source the chips, for example, that they needed. And also they could not keep up with the technology changes, because many times what happens is that some of the ICs, some of the parts that we use become obsolete. They were no longer made. So you have to redesign the product with new parts that are available. And so this just it becomes very difficult for some companies, but we've been in this business long enough to know and work ahead to develop this type of a pipeline that allows us to redesign fast and also source chips. So parts that are needed to build the product. And what is key to us is the ability to rapidly ship. As you probably know, most customers will wait 6 months, with an order, but when they order, they want 15, 20, 50 units. They want it in days or weeks. And if you don't have that product, then you're not going to get the business. So we have been lucky to build up a $7 million inventory that allows us to ship very rapidly from this inventory. The product is not going to be obsolete. We can upgrade even a 5-year-old product to the latest firmware to make sure that it still works with the latest generation firmware that we have developed, latest modems that we have developed with the customers. And so we have this huge advantage to do that. It's a niche market that we are servicing, but it has a potential, and the resellers that we have around the world would be selling the electronically steered phased array antenna for us. So it's a follow-on business for us developing this new technology, and the existing technology will stick around for a while. There's a lot of satellites up there with 10 to 15 year life cycle, and both Hughes and Viasat, for example, are launching geostationary satellites. So it's not like the business is going anywhere.
Yeah, you in the presentation, you talked about sort of the industry sort of direction or things that are happening. I mean, thousands and thousands, if not tens of thousands of satellites up in space. I imagine that technology is improving. I keep hearing about the cost of satellite data dropping. Where's this going, and what sort of new sort of business opportunities do you see because of this, call it drop in data, or new technology that's out there?
Well, because of the modularity of the electronically steered antenna that we have developed, we can build a very, very small satellite antenna. So for example, if you want a self-driving tractor or something like that, that requires very little bandwidth, but it needs connectivity to a satellite, one of these 4x4 elements can be put on a tractor, for example, hopefully very inexpensively, and that would be an IoT type of an application. So that is a completely different animal from broadband. It's low speed, but it still requires data, and it requires it in areas where there's no connectivity. So that is another segment of the market that will automatically follow from what we have developed. And that market is going to be astronomical in terms of applications. So there'll be many, many applications requiring very low data rates, but they will need still to communicate with a low Earth orbit satellite.
That makes sense. I've got a question. I might as well ask it now, but somebody's asked, so Starlink's a subsidiary of SpaceX. It's a closed system. Kuiper or Kymeta, are they closed systems as well? And maybe talk a little bit about that. When we spoke last, you also talked about sort of different governments now. Obviously, they want their own satellite networks where, they're setting up their own satellites. So I imagine there's a lot of different corporate opportunities, but government opportunities because of this idea of closed networks.
That's correct. So for example, I was in Saudi Arabia, 2 months or 3 months ago, and they will not allow Starlink to operate there because they want to have control over the data. The same is with China, with Russia, and many other countries that will not allow. India, for example, is reluctant to have certain applications on a satellite that is not based in the country that the data is being stored in. So those are also all potential applications for our antenna, because our antenna is agnostic. It doesn't care if it's an Indian or a Chinese or a Russian satellite. It will work with those satellites, and if they're low Earth orbit, they will need an antenna similar to what we have developed. So that market is going to be there, and it's a commercial market. It's not a consumer market. So the Starlink is a commercial closed market. You need to buy their modem, you need to buy their antenna, and you need to use their service. The antennas that we are designing will work with any type of modem on the market, any type of LEO satellite, specifically in the Ka band frequency range. So it gives us the opportunity to sell to anybody and not be locked into one provider or another provider. So, and again, we don't provide the connectivity, we sell the hardware, and the resellers connect the hardware to a particular satellite in a particular country.
Mm-hmm. So, I mean, so you theoretically, you can sell to SpaceX, to Kuiper and all these other networks, if they so choose to use your antenna. Is that correct?
Yeah. We for example, SpaceX is Ku band, so it's a much lower frequency than what we are developing. Amazon or Kuiper is a Ka band, but again, they have their own service, they have their own modem, and they will have their own antenna. So it's very unlikely that they would buy our product.
Right.
But anybody else, like Telesat, for example, will be an open system, and all of the geos around the world are going to be open systems, and many of the other services that are Ka band based are going to be open systems. So there will be a very large market for us, and we are not chasing the consumer market. We are completely staying away from that.
Yeah, it's staying with commercial.
So the Hughes, the Viasats, the Eutelsats, they all will be potential customers because they have geostationary systems, and some of them will have LEO systems that will be open, to antennas similar to ours.
Gotcha. Let's talk a little bit about the company and the stock. Financially, how much cash did you say you're sitting on?
It's about 34 million in working capital. Cash is about 17 million.
So 17 million cash, 34 million in working capital. Okay, that's perfect. Not much in the way of debt, I believe. Zero debt. That's correct. That's fantastic. And then as far as the share structure, 42 million shares outstanding. Now you're a significant shareholder. What's the insider percentage ownership?
Probably about 50%.
About 50%. Okay.
I own about 40%.
Okay, 40% CO. Perfect. And then you issue a dividend. I think you're paying about 5 cents a year, if I'm not mistaken. Okay, good. So that's obviously what you're doing with some of the capital. I think we touched on it when we spoke last. Do you look at a share buyback? Do you look at sort of what do you see as that cash that's sitting on your balance sheet? What do you think is the best use of that cash over the next few years?
Well, it's security. That's all it is for now. It's essentially, if we want to launch another R&D project, for example, where we would need a couple $1 million, it would be better to have that cash available rather than kill the dividend. For example, we pay out about $2 million a year in dividends. So the cash is used for that. But I've always believed that cash is king. And as you can see, probably from this type of an environment that we are in, it's probably very difficult to raise cash when you need it. So I don't know. I don't sleep badly with having cash in the bank. It would be different if it was the other way around. But I think that I believe that we can probably, if we have a couple of good years, we may do a special dividend and give some of it back to the shareholders if it becomes too much. So we did a share buyback once. It was a total failure, and we could only sell about $300,000 or $400,000 worth of shares because most customers or most shareholders were not parting with their stock. So the stock is also already illiquid. So if you buy back a lot more shares, you'll make it even more illiquid than it is today. So it's a chicken and an egg type of situation. And I wish somebody could give me a magic formula that would satisfy my love of hoarding cash to be able to just blow it out and do something with it. But so far, I've not been able to find anything that came up with a good idea.
Well, you've got the added benefit now that you actually get an interest payment on the cash you're holding. You're making some money there for sure. Okay, well, this is good. I got a couple other questions. Maybe you can answer them. They should be quick answers here. You know, we talked about the high altitude plane project that you're working on. I've got a question here. Could you use larger programmable drones instead of the airplanes? I mean, that's in essence what we're talking about. These are
These are
unmanned vehicles.
these are unmanned vehicles. They're the
Yeah.
size of a football field.
Yeah. So they're basically large drones.
Yeah,
Exactly.
they are large vehicles, and they are full of solar panels. So
Yeah.
90% of the plane is solar panel.
Yeah, that's amazing. And I've got another question here. It says, is the business generating cash? Now, clearly you're generating cash, but one thing I've noticed in the past is like there's not consistency to your business on a quarterly basis, maybe on an annual basis, but you tend to get large orders and then maybe they don't show up the next quarter and then more orders. Is that the way to frame it?
That's the way, unfortunately, the business is. The
Yeah.
first quarters are generally weak. Second quarter is a little better. Third is a little better. And fourth quarters are generally very large. And there's no rhyme or reason or logic or anything to it. It just happens. You know, sometimes we got an order from an Indian army for $6 or $7 million, and it just walked through the door. Boom.
Yeah.
That was it. You know, it's
no warning whatsoever.
yeah, no, so there's no warning, no you know, just and we are working now with a oil and gas company that is trying to replace 400 of their antennas. And so again, you know, if we get you know, a percentage of that, that could be very, very large. And the chances are that if we start selling to them, they will probably buy only our antenna.
Yeah. Now, is there, I've always believed there's a sort of a cycle or a refresh cycle that comes into this industry. You'd mentioned that satellites have a lifespan. Is that the way to frame it? Do they have to sort of upgrade technologies from time to time with your type of equipment?
Well, they do, mainly because our antennas are mechanical devices. So ultimately, they, you know, especially in the desert, they break down after so many years of heavy usage. The military guys are known to throw product very, very hard, so they destroy things. And so there is a repeat business from that particular segment of the industry, but we sell a lot of spare parts to them, and they can fix the antennas in most cases. But they also replace them with newer antennas because they wear out ultimately. And there is also new modems and new hubs and new developments that happen on the satellite, and especially on the frequency side, where they move from the Ku band, which is a lower frequency range, to a higher frequency range, and then there is changeover for that to happen. So it is, you know, once you have a service on a 15-year-old satellite, chances are you're going to stick to it for a while, unless there's a better price somewhere else, and then you have to move to another satellite operator. But generally speaking, it's a very stable industry. You know, there's not much upheaval in it in terms of technological changes.
Yeah. Another question just came in, just in regards to, is there any kind of recurring revenue or
no,
you know what? Yeah, so it's more or less a one-time sale all the time, right? You're getting repeat business, but not recurring. Okay.
Yeah, one time and then repeat to the same customer.
Yeah.
For example, Halliburton has 1,000 of our antennas with Hughes. So Hughes bought the antennas and deployed them for Halliburton. So it's a one-time deal, but it was over a number of years. They just kept adding to it. So it is not a recurring revenue model.
Yeah, no, fair enough. Okay, so last couple questions here before we wrap up. So as investors sort of paying attention to the business now, what do you think are the key metrics or maybe even catalysts that we should pay attention to the most to really understand how successful you guys you're growing the business?
Well, I expect that next year should be a better year than this year in terms of what we are seeing in terms of backlog and some potential orders that are coming in large numbers. And also we hope that a year from now, we will have this electronically steered antenna on the market, tested with a number of satellite operators, and start to sell the product. So that will be what we will be doing is probably making announcements as this antenna rolls out. We are in the final stages, as I mentioned, in manufacturing of it, and we are going to be testing it. We already tested the design over Telesat, so we know the design works, but we are building a 4 times larger capacity antenna, and so we want to make sure that all of its components and everything put together will work. And let me just cancel this here. And we will making announcements of these phases of this antenna development between now and next year.
Mm-hmm. And Leslie, you know, I think of this, and somebody just brought it up as well. What's the end goal here? What do you think happens to your business? Are you one day, do you expect to be acquired? Do you expect to ever, you know, do any acquisitions? What do you think is a potential end goal here?
I would prefer to be acquired rather than me acquiring somebody.
Mm-hmm.
But I think that the technology will be so valuable at some point that somebody who will need this type of technology will want to acquire it either for military use or a particular use for themselves, not sharing it with anybody else.
Right.
That would be the end goal, would be to sell the company to somebody who would see it as a valuable asset to acquire, not at $1, but you know, something a little bit higher than that.
Mm-hmm.
And that would be the end goal of passing this on to somebody who could move it to the next level.
Mm-hmm. Yeah, no, fair enough. So sort of as we wrap up here, is there any sort of thing that we missed, or any key message you want to make sure everybody walks away with today?
Well, I just wanted to probably communicate that the stock is, in my opinion, undervalued based on the performance of the company, based on its health, based on its ability to generate high margin cash. And we are hoping that going into the next couple of years, we will be able to generate a much higher EBITDA than we have generated so far, based on the fact that very few competitors now exist in the marketplace, and also that we are penetrating, you know, worldwide market with this technology, and our product is becoming a de facto standard in many of these type of applications where it's used. And we hope that the phased array antenna will take over from there and also leave a mark in the industry. So the shareholders should watch the company, and I think that it's time to step in and buy some shares because it's cheap.
That's perfect. That's a great way to end a conversation like this. We've been speaking to Dr. Leslie Klein, CCOM satellite, symbol again is CMI on the Venture Exchange. Fascinating stuff, Dr. Klein. Really appreciate the time you spent with us today. Thank you so much, and we look forward to catching up in the near future.
Thank you, Paul, and thank you to your attendees. And if they have any questions, they can always contact me. Happy to talk to them.
Appreciate it.
Thank you.
Bye. Bye for now.